Assalamualaikum dear students. I'm recording today's lecture because we have missed class because it's very close to the Eid. But the topic which I'm going to cover in this lecture is very closely related to what we have already done yesterday. So I didn't want to miss this chance. Okay, and have a big gap between the two relevant topics. Okay, so yesterday we have started the topic of level of service and capacity. We defined what is capacity, what is level of service. We talked about highway capacity manual, and I already mentioned that we are only going to cover the uninterrupted flow facilities, and they can be freeways, multilane highways, and two-lane highways. I showed you ideal capacities for these facilities, and we discussed the level of service concept as well, and there are 5 levels of service: A, B, C, D, E, and F. Sorry, six levels of service. Okay, and I already defined what are the conditions for freeways and multilane highways. One thing which I already mentioned was that for freeways and multilane highways, the procedure for calculating the level of service is same. Okay, so they follow the same procedure. So if you want to calculate the level of service for freeways and multilane highways, the first thing you need is free flow speed. Okay, and there are different methods by which you can get the free flow speed, but one of the methods we already discussed earlier, which was doing a spot speed study. Okay, so a spot speed study fulfilled with all its conditions gives you the free flow speed. So normally the traffic tends to maintain the free flow speed at least to a flow of 1000 vehicles per hour per lane. This is normal for freeways and multilane highways. After that, you may have a dip, you may not have a dip depending upon the design of the highway. But up to 1000 vehicles per hour per lane, in these two types of highways, normally we don't see any changes in speed. Okay, so for both these types of highways, the procedure to calculate the level of service depends upon a curve which we have seen again earlier as well, which is the speed flow rate curve. So you have flow rate on the x-axis and speed on the y-axis. Okay, and one of the trends I already mentioned, which is this one, that the flow rate goes up to 1000, the speed doesn't decrease, then you have a dip in the speed in a subtle manner, in a gradual manner. So it's not a sharp dip. Okay, and this curve goes up to capacity. The last point of these curves is the capacity. So for level of service analysis, you have to either plot this curve or at least use the equation of this curve. Okay, so you will use this curve in one way or the other. When you are plotting these curves or using the equation of the curves or going through the analysis of level of service and capacity, they are based upon some base conditions. Base conditions, in raw terms, we call them ideal conditions. Okay, so one of the ideal conditions I already mentioned with the capacity, which is having all passenger cars. Okay, having all passenger cars, meaning then there are no heavy vehicles. Okay, so the entire flow is passenger cars. And then we have another ideal or base condition, which is driver population is regular or familiar users of the facility. Okay, so all the drivers are regular and familiar users of the facility. Another term used for them is commuters. Commuter. So a commuter is a person who regularly uses a service, a transport service. Okay, so what does these conditions do? When all vehicles are passenger cars, the flow reaches the maximum value, because passenger cars they follow the lanes, they have more tendency to follow the lanes, and their speed is higher, the acceleration is much quicker, and so on and so forth. So they present the ideal case for a vehicle. And for drivers, the regular drivers, the commuters, they present the ideal condition for drivers, because a regular driver knows when to change the lane, he knows how to drive. Okay, so usually then they are going faster as well because they are more confident. Okay, so this is why we call them the ideal conditions, the base conditions. So in level of service and capacity analysis, these two conditions are used or taken into account in the procedure of highway capacity manual. Okay, now a brief description about the level of service. So level of service A means it's the best condition of traffic flow. We have free flow, so the flow rate is almost zero. So when you are in this condition, you are not influenced by the other drivers. You are selecting your own speed. Okay, you have enough gap between you and the other drivers that you don't feel the need to respond to their changes. If you need to change your lane, you will easily find the gap in your lane as well as the other lane. Okay, and if you have a blockage in one of the lanes, then you have enough gap to go to the other lane without any disturbance in the flow. So a small blockage or a minor disruption doesn't cause the flow to stop in this case. The average spacing between the vehicles is approximately 24 car lengths. Each car is around 18 to 20 feet. So 24 car lengths means 480 feet. Level of service B is still considered free flow. So in urban and rural highways, this is up to this point the speed doesn't drop. So we have more drivers around you, but you still feel that I have enough gap to select my own speed. Okay, but now you are more cautious about the other drivers. You can see them more closer to you. So you are still selecting the speed, but now you are more careful. Okay, your comfort and convenience is slightly less now. Okay, you are selecting, but you are still looking at the other drivers. You are now worried about them. Maneuvering is still easy, but you have to be more vigilant. You have to take more care, more caution. Okay, and still there are gaps available so that any minor disruption or blockage will not stop the flow. Okay, and the spacing in this case goes up to 15 car lengths or 293 feet approximately. Level of service C is still considered free flow, especially for urban highways. Okay, this is called as a practical capacity for urban highways. So especially in urban highways, you will see that up to level of service C, the speed doesn't drop. So now your maneuverability is restricted. Maneuverability meaning, yeah, if you want to change your lane, change your direction, okay, then you are restricted now. You may need to look for a gap. So obviously now you have less gaps, and you need to be more careful in selecting your speed and so on and so forth. And because there are less gaps available, if there's a disruption in one of the lanes and you want to change your lane now, you may not have the chance. So this disruption can actually cause the flow to stop at least in your lane, and then obviously one lane can affect the others as well. So the spacing in this case is up to 10 cars, and this is approximately 203 feet. Okay, level of service D in urban areas, rural areas, you have gone beyond the practical capacity. So now the flow, any increase in flow results in decrease in capacity, decrease in speed. So drivers are now more regularly responding to each other. Okay, they are more closer to each other. Okay, and when the speed decreases, the speed has an inverse relationship with the density. So density is now increasing. Okay. So to go from D to F is not a big range. There is not a big range to go from D to F. We will later do an example as well, which will show this. So going from D to F, there is not a lot of margin. So from A to C, there is a very long margin. There is a very long range of flow rate in which you are not reducing the speed. But when you reach D, to go from D to F, the difference between D to F is not so much. So now you are very close to a breakdown now. Okay, so so minor disruptions in this case can affect the flow to stop. Okay, so again the main thing is that there are less gaps. The gaps are reducing. That's why the density is increasing and the speed is reducing. So all these things are related to the gaps. More vehicles on the road, they are very closer to they are now closer to each other. So you can see the spacing is less now, and then you see the effect. So in this case we don't want any minor disruption, because as I said, once the flow stops, it can very easily go into the F zone. Okay, because there's not a lot of flexibility available. Then we level up service E, which is very close to the capacity. Already mentioned, capacity is a reasonable term. So within E, within the range of E, you have the capacity. Okay, so capacity means what? The highway is fully saturated now. Something is fully saturated, you don't have any extra space. No extra space means that yes, if the vehicles are moving straight, no problem, they can still keep on moving. But any other maneuver will eventually stop the flow. There's no question about it. It's not a question of whether he will find the gap or not. There's no gap. So the flow has to be stopped for any usual maneuver as well, any routine maneuver as well. For example, changing the lane. Changing the lane is routine. Okay, and it happens very often. But even this small maneuver will eventually cause a disruption in the flow. So in level of service E, although we call it the maximum flow, but because of the maneuvering of the drivers at level of service E, you will see the flow is actually stopping and starting. So now we don't have any gaps to use. Okay, so in this case, like I mentioned, if somebody wants to change the lane, he will give the indicator and do whatever he wants, but until the other guys give him the space to do it, the chance to do, he cannot do it. Okay, so this is level of service E, and then after that we have F. Okay, we don't want to talk about F. F is not good for us. Okay, so average spacing in this case up to 6 cars, which is almost 117 feet. Somebody may say that 117 feet is a very long distance, more than 30 meters. So why we are saying that there are no gaps? There are no gaps for moving traffic. If you want to park your car, 117 feet is a lot of space for you. You can easily park maybe 2-3 cars in this space. But when the cars are moving, you don't prefer to go into a spacing of 100 feet or so. When the car in front of you and the car behind you and the car in the other lanes, all of them are moving. So it's a very small margin. Usually people will not take a chance. Okay, and even if somebody takes a chance, the other drivers may not feel comfortable, so they will usually stop. Okay, so 100 feet in a moving flow is not too much. Okay, so this is a description of the levels of service which I wanted to do before we go on for the Eid break. So Eid Mubarak in advance to all of you.